Oops. Okay. Let's look at number 6. Alright, so in this question, notice that this is actually the difference quotient, or the slope of the tangent line. Anyway, we want h to be 0. So now remember, the first thing when the first thing you do when you're doing a goodness gracious, a limit, first thing you should do is try to plug it in and see what happens. So I plugged in a 0 for h. That would give me the square root of 1 minus 1 over 0, which would be 0 over 0. Now, this is actually kind of a good thing. If you get 0 over 0, that means you can play with it. Okay, so play with it. Okay, so whenever you try to plug it in and you get 0 over 0, now remember this isn't for piecewise. Piecewise you have to look at each side, but if you get 0 over 0, that means you can play with it. There's several ways we play with it. One of the first ones is to think about factoring. Another one is to think about multiplying by conjugates. Another one is to think about like trig substitution. That's if it has trig in it. I swear there's another one that I'm not thinking of right now. But anyway, this one we see that square root, you should think let's multiply by the conjugate. So, remember the conjugate of a plus b is a minus b. So essentially you just change the middle sign, and you want to do that with the one that has the square root in it. So we have 12h plus 1 minus 1 divided by h. So what I'm going to do is I'm going to multiply by the number 1, but I'm going to pick a special one. It's going to be the conjugate of either the numerator or the denominator, whichever has the square root in it. So see, I'm multiplying by the number 1, and it's the conjugate of the numerator in this case. So whenever you multiply conjugates, if you recall what happens, a plus b times a minus b would be a squared minus ab plus ab minus b squared. So see, what happens is you just end up with the first one squared minus the second one squared. So in other words, we just get 12h plus 1 squared minus 1 squared. See, the first one squared minus the second one squared. On the bottom here, now I am not going to multiply this out. Remember, the hope is that the h goes away. That's what we're hoping is going to happen here. So when you square a square root, you essentially get the inside, because they are inverses of each other. So the top looks like that. And the ones cancel. So we get 12h over h times 12h plus 1 plus 1. All right, so see what happened. The h's divide out, and we have 12 over the square root of 12h plus 1 plus 1. Now that we have manipulated it, so when I said play with it, that's what I meant, let's try to plug the 0 in again. So we've played with it, and now we're going to check out plugging in the 0. So 12 divided by the square root of 12 times 0 plus 1 is going to be 12 over, and that is, I almost said the square root of 13, the square root of 1 plus 1, which is 12 halves, which is 6. So pretty cool. So again, the key is that if you plug in and you get 0 over 0, that means you need to play with it and see what happens. You should be able to get to a value. Okay, now if it's 5 over 0, that's a different story. If it was 0 over 5, that's just a 0. So it's when it's 0 over 0 that you should check out playing with it. All right, let's look at the next one. All right, so again, let's try, this is a rational function. So remember, the first thing to do is just see what happens if you plug in. So again, I'm just going to kind of pretend like I'm going to call this f of x so that I can say, let's see what f of 7 would be. So that would be 7 squared minus 4 times 7 minus 21 divided by 7 minus 7. So on top, we're going to get 49 minus 7 times 7 is 49. 4 times 7 is 20. Oh, see what I just did? (49, 28, 21) over 0. So notice we get 0 over 0. So again, you get 0 over 0, you should think, I should be able to play with this. So remember, one of our first ways of playing with it is to try factoring it. And this is a rational function. Let's factor the numerator and denominator separately and see what happens. Actually, the numerator, or the denominator, doesn't need factoring in this case. But let's check out x squared minus 4x minus 21. And we want to see if we can come up with two numbers that multiply to get negative 21 and add to get negative 4. So let's see, how about a 3 and a 7? And I need to pick one to be negative. So I'm going to pick the 7 to be negative. They multiply to get negative 21. They add to get negative 4. So that means we're going to put a plus 3 and a minus 7 here. So notice what the rational function would be equivalent to here. We'd have, oh, almost dropped my pen. So we'd have x squared minus 4x minus 21 over x minus 7 equals x plus 3, x minus 7 over x minus 7. And now these guys divide out. So now I mentioned on the previous video, if the denominator in a rational function divides out like this, that doesn't mean that 7 is okay. Because see, the domain here still excludes the number 7, right? This is the domain of this function. So something is going on there. What happens is, if it divides out like this, there's actually a hole in the graph there. So this graph, if we were to graph this polynomial, it would actually just be x plus 3. So it would be this line here, but it would have a hole at 7. There's a hole right there in the graph. So we can find out what the limit is by plugging the 7 in, now that we've played with it. So we just played with it, and now this is what it looks like. It just looks like x plus 3. So let's plug the 7 into this, and we get 10. And that's our answer. So again, we got 0 over 0, so we said, let's try to play with it. It's kind of, you look at it, let's factor. So after factoring, the bottom divided out, and we got a 10, and that is our answer. All right, let's look at the next one. All right, so this time u is approaching 4. So again, I'm just going to kind of take this out and call it f of u, and let's just see what f of 4 is. So if I plug in a 4, I get 4 to the 4th minus 256 over 4 cubed minus 64. Now 4 times 4 is 16, times 4 again would be 64, and 64 times another 4 would be 256. So we get 0 over 0. So that means let's check out playing with it. And the top is a difference of squares. So if you look at the top, you can think of that as u squared squared minus 16 squared. And on the bottom, we actually have a difference of cubes. This is u to the third minus 4 to the third. And differences of squares and differences of cubes both factor. So let me remind you of those formulas real quick. A squared minus b squared. We actually just made this happen earlier. Remember, this is a product of conjugates. For the cubes, this one you might not remember, but I'm going to write down SOP real quick. This helps you remember the signs. That means same, opposite, always positive. Oops. So some people say SOAP. Same, opposite, always positive. So what we're going to do here is the first sign is the same, so a minus b. And then we have the squared in here, so this is a squared. And then you have the opposite sign, so plus. And then you have the product of the two, which would be ab. And then you have always positive at the end, and that's b squared. Okay, if this had been a cubed plus b cubed, we would have had same sign, opposite sign, always positive. So you see how the signs work, same, opposite, always positive. All right, so now that we know how to factor it, let's go back to our problem. So what we have here is So what we have here is u squared plus 16, u squared minus 16. So that's our difference of squares from the top. So you see the thing inside the parentheses here. That's your a and your b. So our a was u squared and our b was 16. All right, and so then divided by on the bottom, we're going to have u minus 4, u squared, plus 4u, and then, oh, is that supposed to be a 2? Give me, here, let's just check this real quick. A cubed plus a squared b plus ab squared minus a squared b minus ab squared minus b cubed. No, that was right. Okay. All right, so we have, sorry. So first off, notice that this is my a and this is my b in this case. So we have a minus b, and then we have a squared plus the product of the two, and then plus the 4 squared, which would be 16. And then we look at this and say, okay, well, that didn't help. I still can't plug the thing in. But wait a minute. Look at the top here. This is a difference of squares again. So on top, we actually have u squared plus 16, and then we have u plus 4, u minus 4, and on the bottom, u minus 4, u squared plus 4u plus 16, and we see that the u minus 4s divide out. And notice the u minus 4 is the factor that was causing the 0 over 0, right? Because we were plugging in a 4. So see, the 4 here makes a 0, and the 4 here makes a 0. So those are gone, which means the graph itself has a hole at 4. So if there's just a hole in an otherwise nice continuous function, then it must have a limit, and we can figure out the limit by plugging back in again. So I'm going to, so what we have right now is u squared plus 16 and u plus 4. In our denominator, we have u squared plus 4u plus 16. Let's plug the 4 in again. And we're going to get 16 and 16 is 32. 4 plus 4 is 8. And on the bottom, we're going to get 16 3 times, which is a 48. Oh, goodness gracious. All right. 8. I don't know, whatever. Half of that is a 4. Half of that is a 24. 4 goes into that once. 4 goes into that 6 times. So 32 over 6, which is 16 over 3. Sorry, I'm a very slow reducer. Oh, duh. 8 times 6 is 48. Okay, so 16 over 3 for our answer. So that was another factoring. All right, let's see. Number 9. Looks like this will be another conjugate. So let me just set it up for you. Let's not do this whole thing. But let's just see what we would do. So again, the first thing you would do is try to plug in the 3. 3 times 3 is 9. We'd have square root of 25 minus 5 over 3 minus 3, which would give us 0 over 0. So then we think to ourselves, oh, let's try to factor. Well, this isn't a factoring guy, but it does have a square root in it. So what we're going to do is multiply the top and bottom by the conjugate of, in this case, the numerator again, because that's where the square root is. And again, don't do anything with, in this case, the denominator. You do not need to try to multiply that out, because what's going to happen when you're done with this is the x minus 3 should cancel, okay, should divide out. So, but we'll just go on to the next one. We did one very similar to this already. And so again, just kind of FOIL out the top, or a squared minus b squared, and then with the bottom, and you'll have that. Actually, I kind of want to look at this one now. Oh, that's why it was messing me up. I was like, why does it doesn't look like it's going to work. Okay, never mind. There it goes. All right, so let's look at another one. All right, let's look at number 10. All right, so in this one we have a trig function. So let's see what we're going to do here. All right, so the first thing we're going to do is we'll just call this a function. We'll call it f of x and just say, you know what, I'm going to check out f of 0 and see what it looks like. So we're trying to find the secant of 0. But secant, if you recall, is 1 over cosine. So let's think to our unit circle. This is 0 and pi over 2 and pi and 3 pi over 2. So 0 on a unit circle where the radius is 1, this would be the point 1, 0. And remember that this is cosine sine. So the cosine of 0 is actually 1, which means this is 1 over 1, which is 1. And we're done, actually. So we knew that one. The other thing, you could graph actual secant here, if you recall what that looks like. This is 1 period of it, where that's 2 pi, and this is 0. This is what cosine looks like. So recall that secant has asymptotes wherever he hits 0, and then kind of bounces off like this. So if you were to actually look at the graph, what happens, and remember this does keep going, okay, so what happens as you approach 0? Well, if you approach 0 from this direction or this direction, where are you going? You're going to 1. You see, the answer is 1. So if you remember the graph, you can also see that. But nothing funny going on there. We just had to plug it in. And we'll actually stop there on number 10.